Hello friends, welcome back to Brinda and B2 Vlogs. Today I'm going to explain you what do you mean by chemical reactions and its types. Now, what do you mean by chemical reactions? A chemical reaction is a process in which one or more new substances with totally different properties are formed. Those are only mean by chemical reactions. Then what do you mean by chemical equation? A chemical equation is a symbolic representation of a chemical reaction by using many formulas or symbols and the substances which is involved in that reaction. So here we use the formulas or the symbols to represent any reaction. So these are many. I gave you an example here. This 2H2 plus O2 gives you 2H2O. Here they are using many symbols and formulas to represent this as a chemical reaction also. The chemical equation, and here these are H2 plus O2 is the reactant and H2O is the products. Always remember they should be in a balanced equation. Next is, let us see about the different types of reaction. The first type of reaction is a combination reaction. What do you mean by combination reaction? I have represented it. A plus B gives you AB. How many other products, reactants it may be, but it should be a single product. So this combination reaction is a reaction. It is a chemical reaction in which one or more than one or two or more than two substances they react to form a single product. So that is only meant by combination reaction, or it is also called as direct combination reaction or synthesis reaction also. Here, this combination or direct combination reaction can happen between two elements. This is only between two elements is called as synthesis reaction. This between two elements is called as synthesis reaction. The synthesis reaction between two elements. Now here I have given you one example. H2 plus O2 gives you H2O. You should be in this reaction should always be in a balanced equation. So 2H2 plus O2 gives you 2H2O. I have balanced it also. Mg plus O2 gives you MgO. 2Mg plus O2 gives you 2MgO. And here we see an observation, that is dazzling white bright light is the observation here we can see. Here the second point is that it can happen. So the first point is happening between the combination reaction happening between elements. The second one is between an element and a compound. For example, CO plus O2 gives you CO2. That is 2CO plus O2 gives you 2CO2. And the third thing that can happen between two compounds. CaO plus H2O gives you CaOH twice, and here NH3 plus HCl gives you NH4Cl. Here also we see an observation, that is dense white fumes. Here ammonium gas is lighter than the HCl gas, so it moves faster, and HCl gas is heavier than air. So only here we can see NH4Cl formed. Next, let us see about the next type of reaction, that is decomposition reaction. In decomposition reaction also, but you have a slight difference between direct combination reaction and decomposition reaction. That also let me tell you what is the difference. So decomposition reaction. A decomposition reaction is a reaction in which a reactant decomposes to form multiple products. For example, let me represent it. AB gives you, or AB decomposes to give A plus B. So here AB is decomposing to give A plus B. Here we have many examples also. So first let me tell you the definition of this decomposition reaction. Once again, decomposition reaction is a chemical reaction in which a reactant, so this AB is a reactant that decomposes to form A and B. These are two products. Multiple products also it may be. Your best example is the acidified H2O. This H2O water should be acidified to give H2 plus O2. To break down, water should break down into hydrogen and oxygen. Then it should be acidified water with the presence of electric current. So when electric current is passed to the acidified water, it turns into hydrogen and oxygen. So we have two tests for hydrogen and oxygen also that we will see in the later part. So this is an electrolytic decomposition, and you have to always balance the equation. 2 2s are 4, and here also I put 2 2s are 4. So hydrogen is balanced. 2O, here 2O. So it's a balanced equation. Now let me tell you one more equation for this. For thermal. Now let me tell you for thermal. CaCO3. Here CaCO3. It decomposes to form CO plus CO2. So this is a self-balanced equation. So here there is a test for CO2. When the CO2 is passed to the lime water turns milky. So there's a reaction for that also. CO2 plus. You have to always remember what is the formula of lime water. Many of them have a tendency of writing Slakered lime's formula, but Slakered lime and lime water is different. When lime water turns, then only it forms Slakered lime. So plus CaCO twice gives you what? CaCO3 plus H2O. CaCO3 plus the water is liberated. Okay, so water is H2O. So I repeated, CO2 plus CaOH twice gives you CaCO3 plus H2O. This is also self-balanced equation. Now let us see one more thing. Here we have one more equation. KNO3. KNO3. Here this is a nitrate. Here potassium nitrate it is. Gives you KNO2 plus O2. So let us balance it. 2KNO3 gives you 2KNO2 plus O2. Here we have to see the test for O2. As I told you, here I'm going to tell you the test for O2 or oxygen. When a glowing splinter is brought or is introduced into a test tube containing oxygen, it rekindles or glows brightly. It glows brightly or it rekindles. That is your test for oxygen. And then let us see about the decomposition of nitrates. How are nitrates decomposed? 3 as an example. Let us see one more example like that. Pb. What do you mean by Pb? It is lead. Pb means lead. So PbNO3 twice gives you have to always guess it because here 3 products are formed. Because PbO plus. PbO is one product. NO2 is another product. And oxygen is liberated. So you will have also 3 observations over here. So let us first balance the equation. So here PbNO3 twice. First you can balance it by seeing the equation only, you can balance it, or else you have to write the reactants and products in both the sides, and then you have to balance it. So I'll just see the reaction and then balance it. So here Pb is balanced. So I put here 2 Pb, here also 2 PbO. So here plus 4 NO2 plus O2. So the equation is balanced. Now let us see all the observations that we see in this reaction. First observation is first we let us see about the O2. First let us gas. So a colorless gas, which is colorless, odorless gas, is liberated, which is rekindles a glowing splinter when introduced into it. Second observation is, so first observation is based on oxygen. So first observation based on oxygen, you have to tell the test for oxygen. Second observation is nitrogen dioxide. You have to tell reddish brown. Always remember, not only brown, you have to, ICSE always prefers reddish brown. So you have to write reddish brown fumes. It is a fumes of NO2. So reddish brown fumes of NO2 is the second observation. And the third observation is the white colored PbNO3 twice changes into a yellow residue. Residue means the leftover part. When it is heated, the leftover part is the yellow residue. Okay. So now let us see, here it is heated. So here heat is provided. So we put this symbol, this arrow mark. Okay. Now let us see about one more reaction. Same like this. It is of copper. Same observations, but just a change in reaction. So let me write the reaction. CuNO3 twice gives CuO plus NO2 plus O2. Here balancing done. Then first let us see, the first observation is the oxygen. You have to do the oxygen test. That is, when odorless, colorless gas, when introduced into a glowing splinter, it glows brightly or it rekindles. Then the second observation, reddish brown fumes of NO2. And the third observation is wrong. For this one, you have to write it as bluish green. CuNO3 twice, bluish, it is bluish green in color. It changes into a black residue, or leaves behind a black residue. Okay, so this is the observation. And now let us see the decomposition of sulfates. As we finish this decomposition reaction, there are many decomposition of this nitrates and sulfates. Now let us see about the nitrates and sulfates. We saw about the nitrates, so let us see about the sulfates. One main example that you know about the sulfates is zinc sulfate. ZnSO4 gives you have to split this. This is, many of them make a mistake by writing the displacement reaction for this. It's wrong. So ZnO plus SO2 plus O2. So here also test for oxygen. So one observation will be the test for oxygen. The other observation is for test for SO2. There are two tests for SO2. First one, when SO2 is passed through acidified K2Cr2O7. K2Cr2O7 potassium dichromate solution, the orange color changes into green color. And one more test is that when SO2 is passed through alkaline KMnO4, it is potassium permanganate solution. The pink color becomes colorless. So this is about the decomposition reaction. Now let us go to the displacement reaction. This displacement reaction is a little smaller only. It is not much. It is easy also because it is displacing. So it is a displacement reaction. A displacement reaction is a reaction where a more reactive element displaces a less reactive element from its compound. So let me just write two examples. AB plus C gives you, here C is more reactive than A. So here CB plus A is just removed out from AB. So let me give you one example. Zn plus CuSO4 gives you ZnSO4 plus Cu. Here Zn being more reactive than Cu, displaces copper from copper sulfate solution. So your zinc is there and copper is just removed out of the copper sulfate solution. One more best example is F plus HCl gives you Fe what? It may be 1 or 2. Fe may be 1 or 2. This you have to, when if there is no mention of, you have to take it as 2. So FeCl2 plus H2. So we have to balance it by this equation. Okay. So here also, the here observation is brisk effervescence. When you see hydrogen gas is liberated out, here your observation will be brisk effervescence, and there is a test for hydrogen gas also. When a burning splinter is introduced into a gas jar containing hydrogen gas, it burns with a pop sound and later it is put off. So that is a test for hydrogen gas. We know many reactivity series. You know about the reactivity series? So reactivity series, what is this reactivity series? It is a series in which the metals are arranged in their decreasing order of their reactivity. That is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold and platinum. This is the reactivity series. So you can remember it easily with one sentence. Please stop calling me a zebra. I'll write it down. Please. So P is for potassium. So please stop calling me a zebra. Okay, till here, zebra. I like her calling me smart coach. Please. Okay. So with this sentence, you can remember all the reactivity series: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold and platinum. So these reactivity series. Now let us go to the next reaction, that is double displacement or double decomposition reaction. Double decomposition reaction. Here we have two types of reaction in this double decomposition reaction. One is neutralization reaction and one is precipitation reaction. Here in neutralization reaction, an acid and a base reacts to form salt and water. In neutralization reaction, an acid reacts with a base to form. So acid and a base reacts to form a salt plus. Always remember, when there is a salt and a water, H2O, that is a neutralization reaction. And whenever you see a precipitate form, that is a precipitation reaction. Let me tell you what do you mean by precipitation reaction. In a double displacement reaction or double decomposition reaction, when two aqueous solutions, so first one I told you, precipitation reaction. Two aqueous, AQ, you can represent with AQ. AQ solutions, that is aqueous solutions, are mixed if an insoluble solid is left behind. Now if an insoluble solid is left behind, that is a precipitation reaction, that is a precipitate formed, so that is a precipitation reaction. Okay, so that, let me give you a few examples for this precipitation reaction. Okay, so one example is, you always know white precipitate. NaCl plus AgNO3 gives you, NaCl plus AgNO3 gives you AgCl. So this one with this one and this one with this one. So that you have to interchange. So AgCl plus NaNO3. Okay. So in NaNO3, so AgCl, this precipitation you will show with a downward arrow, and when a gas is liberated, you will show it in an upward arrow. When a gas like H2O, CO2, O2, N2, all these, when it is liberated, you show in an upward arrow, and when a precipitation is formed, you show in a downward arrow. And here the observation is white precipitate of AgCl. So the precipitate formed here is AgCl. One more example here. Silver nitrate solution is a reagent for the testing of the chloride radical. So silver nitrate, here this silver nitrate is used for testing. This is Cl's reagent. So this is the next one. Let me just tell you one example for this. CuSO4 or CuSO4 plus NaOH gives you. Here also you see a precipitate form, pale blue precipitate. Here this is CuOH twice plus Na2SO4. So here you see a pale blue PPT. Here you can use it as precipitate. That's it for today. Thank you for watching. If you like, please share and subscribe.